In this video, we're going to be talking about the sine and cosine of complementary angles. To review here, complementary angles are two angles that add up to 90 degrees. That's going to be helpful in all the problems that we look at today. In our first example, A and B are complementary angles in right triangle ABC. If the sine of A is 5/13, I want you to find the cosine of B. So as soon as I read that A and B are complementary angles, I'm going to draw out my right triangle. Since A and B add up to 90 degrees, I know that they have to be these two smaller angles. One of them alone couldn't be 90. I need two smaller angles that add up to 90 degrees. Now that I have my picture, I can start to work with what I gave for the sine of A. So the sine of A is 5/13. Remember that sine is opposite over hypotenuse. So if I'm anchored at angle A, the opposite side is going to be here, and my hypotenuse is going to be here. Now if I want to find the cosine of B, remember that's adjacent over hypotenuse. So anchored at B, 5 is adjacent or next to angle B, and this is still my hypotenuse. So the cosine of B is still 5/13, so the same thing. The main idea in this video is that if two angles are complementary in a right triangle, the sine of one of them equals the cosine of the other. And this works the other way too. So the sine of one angle, again, equals the cosine of the other. So in your notes, I would have this highlighted. This is going to be the important main point in any problem that you look at today or tomorrow. So here, let's just show how you could even prove this in our calculator or even do some of these problems using mental math. In example problem number 2, I'm telling you the cosine of 60 is 0.5, and I want you to find the sine of 30. So let's say you didn't have a calculator, so we weren't able to just type this in. Just looking at this, I look at 60 degrees and 30 degrees. These are complementary angles. They add up to 90. So I know that the cosine of one angle equals the sine of its complementary angle. So the sine of 30 would have to equal 0.5 as well. Now let's say we find our calculator, type cosine of 60 in, type sine of 30 in, you'll see that they both equal 0.5. You could do this with any two values that add up to 90 degrees. So the sine of 20 would have to equal the cosine of 90 minus 20 is 70. Plug those into your calculator, you see they both equal 0.342 rounded. So that checks out. Cosine of 88 would have to equal the sine of 2. That checks out. Let's try one more. The sine of 37 would have to equal the cosine of 90 minus 37 is 53. And that checks out as well. In the last problem that we look at today, I'm telling you right triangle FGH is shown, so you have the picture of it already. I'm telling you that the sine of F is 0.53, and I want you to find the cosine of H. So you might be looking at this problem and thinking, well, how would I find the cosine or really anything in this diagram? I'm not given any numbers here, but the picture itself tells us all that we need to know. Looking at the picture, I see that F and H are complementary angles, or they're the two small angles in the right triangle, so I know that the sine of F would have to equal the cosine of H. So if the sine of F is 0.53, the cosine of H is also 0.53.